In this video, we will introduce the data lifecycle. That is the steps that we take to transform a research question into an insightful analysis. Simply put, it's a series of steps that I follow every time I approach a new data-focused project. All of our activities in this course are framed within this 6-step process, and each step is equally important. In our data lifecycle, there are 6 steps. We start with defining a relevant, feasible, and open-ended research question. We collect or source data to help answer that question and prepare ourselves to begin exploring and analyzing the data by getting our project files organized. We get our data imported into RStudio, make sure we understand how it's structured, and if needed, we wrangle the data so that all rows and columns are arranged correctly. Variables are named, defined, and formatted correctly, and we are aware of any missing or erroneous data values. We strategically explore the data using numeric summaries and insightful visualizations like plots, maps, and tables to find patterns and trends, as well as to spot any outliers. We use this information to start putting together a strategy for analyzing the data, all in an effort to answer our research question. We build upon our exploration of the data using carefully chosen statistical tests and models to confirm patterns and trends we found in the previous step. And last but definitely not least, we package the whole process together in a well-designed way, whether as a report, a slide deck, a data dashboard, or an oral presentation that concisely answers our research question and makes sense for the intended audience. There are other considerations along the data lifecycle that we won't cover in detail in this course, but are essential to building your data literacy. First, defining a good research question sets the stage for the type of research you conduct and defines the approach to collecting or sourcing the right data to answer the question. By deconstructing a research question into a population of interest, a specific timeline of data, a set of comparisons you wish to make between subgroups within your population of interest, and an outcome, whether or not someone develops a disease, the price of a stock on a particular date based on historic performance and other factors, the percentage of students who achieve a certain score on an end-of-grade exam, or the median household income for families with specific characteristics. Your study design depends on the types of conclusions you wish to draw from the data. If you wish to describe patterns or uncover relationships between variables, then you generally have more flexibility in your study design, as opposed to establishing a cause and effect relationship. In this course, we will be using observational data that has already been collected and mostly organized. Our goal will be to pose research questions that allow us to describe patterns and uncover relationships, and not to claim that action X causes effect Y. I have worked in organizations that relied on data that contained very sensitive information on the health status of individuals. There were many restrictions on the way that data were stored and how we accessed the data so that no individual could be uniquely identified based on their characteristics logged in the data, like a name, address, age, or gender. Also, there were restrictions on how data could be visually presented in tables and plots to prevent the reader from being able to infer the identity of an individual or small group of people. We've seen countless examples of large companies suffering massive data breaches where consumers' personal information was exposed. These breaches not only threaten the safety of consumers' information, but they've also led to a lack of trust in these companies and their ability to safeguard sensitive information. These mistakes are costly and difficult to repair. Thankfully, in this course, we are using data sets that have been made available to the public, so we are free to explore them without worrying about data security. At the end of a research project, it is always a good idea to reflect on the process and document what went well and what didn't. Did you choose a research question that was too simple or too complex? Was there a snag in the data collection process, or were you not granted access to a specific data set that you wanted to use? Did you define variables in the right way, or did you only have access to age groups rather than individual ages? Was your choice of plots and colors and presentation effective for your intended audience? What additional questions did your research leave you wanting to ask? These are all great questions to ask. In particular, the last question is how you build a career in research, by addressing unanswered questions that arise from other research projects. Data stewardship is the process of governing the data used in a project or in an organization. It can involve documenting information about how and when the data were collected, evaluating new sources of data, monitoring who among the organization is using the data and in what ways, and being a trustee of the data. This hidden step of the data lifecycle goes hand in hand with ensuring data security. How many times have you read a research paper or an article and were left with questions about how the data were collected, defined, analyzed, or interpreted? The data lifecycle is structured to create a transparent and reproducible process so that if a peer, a boss, or other stakeholder needs to be able to repeat your analysis, or if you need to revisit a project later on, you have a well-organized set of scripts and results that can be easily replicated. At every step of the data lifecycle, there's potential for bias to be introduced. Whether posing leading questions as research questions, collecting data among an unrepresentative sample of the population you wish to describe, visualizing data in misleading ways that either inflate or minimize differences between groups, using a statistical test or model that relies on assumptions that cannot be verified, or manipulating results to fit a false narrative. While we often don't intend to make these mistakes, it happens every day. It's important to be aware of the potential for our bias and assumptions to tarnish the integrity of our work. In short, this is my general recipe for a well-executed data project. While it's encouraged to follow the steps in order, you may find yourself revisiting steps along the way. And with more experience, you may find ways to refine this recipe to fit your unique situation. In my career in statistics and data science, I have often been brought into projects at the latter stages of the data lifecycle, where decisions, and sometimes mistakes, were made along the way of translating a research question into a data collection and analysis plan. At these latter stages, I was often implicitly asked to fix mistakes through the analysis and interpretation of the data, which is often an impossible undertaking. I want to teach you the data lifecycle so that no matter your role, you understand the important role that data literacy plays at each step. Depending on your role, you may not be involved in or responsible for every step, nor do you have to be an expert at every step, but understanding the whole process can give you context and help you ask the right questions to be a good data steward. The data lifecycle is meant to be a repeating process. With more practice, you will learn how to develop better research questions, collect better data, create better visualizations, perform better analyses, and better communicate your findings with the appropriate stakeholders, which all leads to better understanding. After learning about the data lifecycle, is there a particular step that aligns with your skills and interests? Share your answer to this question in our discussion forum. I can guarantee that you'll find learners who share common interests. Additionally, you'll find others with expertise in areas different from yours. You can learn a lot from them, as well as share your expertise to advance their learning. That's the kind of community that we hope to build in this course. I hope the data lifecycle serves as a useful framework for your research or work. From here, we'll kickstart the data lifecycle starting at step 1, define a research question.